Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. This is lesson 29, word problems. So we're going to take these linear systems and we're going to start answering questions that are real-world situations. And this is where word problems are used. Okay, or where systems are used with word problems. Okay, so the number one says the sum of two numbers is 361. So if I have a number and I don't know it, I'm going to call it x. And if I have a second number and I don't know it, I can't assume they're the same, so I have to call it a different variable y. And so it says the sum of two numbers is 361. So there's my first equation. And the difference between those two same numbers is 173. So the difference is 173. What are the two numbers? So if this doesn't look familiar to you, if I do this, it should look just like lesson 28, and where we had systems of equations where we solved by elimination. So I'm just going to draw a line under here, and I'm going to, let's move this out of the way. Okay, so here are two equations, and I want to eliminate. Well, if I add, I will get rid of the y's, and if I subtract, I'll get rid of the x's. So it doesn't matter what I do in this situation. These x's are the same, so subtracting gives me 0, and these y's are opposites, so when you add opposites, you get 0. I'm going to add. I prefer to add so I don't get confused with the double negative stuff, and you should do the same. So x plus x is 2x. Y plus a negative y is 0. Equals 1 plus 3 is 4. 7 plus 6 is 13. Carry the 1. 3, 4, 534. So now I know 2x is 534, and then when I divide by 2, I will find one of my numbers. So these 2's cancel. 2 goes into 5 twice with a remainder of 1. 6 times 2 is 12 with a remainder of 1, and then 7. So x is 267. So now I need to find y. So I plug 267 into one of these two equations, and it doesn't matter which one. I will choose the first one. So if I have x plus y equals 361, and now x is 267, plus y equals 361, and I subtract 267 to move it over to the other side, then I get y by itself, and 6 minus, sorry, I'm going to borrow from 6 and get 5. 11 minus 7 is 4, and I have to take from that 3 and make that 2, and 15 minus 6 is 9. Okay, so my two answers are x equals 267 and y equals 94. So when I add those, I should get 361, and when I subtract them, I will get 173. Okay, example 2 says there are 356 8th grade students at Euclid's Middle School. So the total is 356. It says 34 more than 4 times the number of girls is equal to half the number of boys. So if you read too much, then it just gets confusing again. So just do pieces at a time. 34. More than means to add, and we always read it right to left. 34 more than 4 times a number. So I'm going to call it 4x. 34 plus and 4x. So that's going to be written 4x plus 34. 34 more than 4 times the number of girls is equal to half the number of boys. Okay, so that's equal to half the number of boys. So how are we going to represent that if we have two unknowns? Okay, so here we need to identify what we're going to call our variables. So we need two variables, so if we let x represent girls or boys, and then we have to denote that somewhere. So before I even go any further than this here, okay, I need to identify, I need to let x equal something, and I want to let y equal something. Okay, so our total will be boys and girls. So I know that I'm going to have an equation, x plus y, boys plus girls, is going to equal my total of 356. So there's my first equation. My second equation is going to be 4x plus 34, where x is 34 more than 4 times the number of girls. So let x equal number of girls. And y be number of boys. Okay. So now that we've done that, this means girls, number of girls plus the number of boys equals 356. And here it's saying 4 times the number of girls plus 34 is equal to half the number of boys, 1/2 y. So there are my two equations that I need to work with. Unfortunately, they're not in the right order, so I'm going to rewrite them. So x plus y equals 356 is already in standard form. But I need to get this x, y, and 34 all rearranged. So I need to move this 1/2 y over to the other side. So I'm going to subtract 1/2 y from both sides. So I have 4x minus 1/2 y plus 34 equals 0. Now I want to move the 34 over to the other side. So I'm going to subtract 34 from both sides. So I get my standard form of 4x minus 1/2 y equals a negative 34. Now if I don't want to deal with fractions, I'm going to truly put it in standard form by not having any fractions throughout. So if I multiply everything by the denominator, I get rid of it. So 2 times 4x is 8x. 2 times a negative 1/2 is 1y equals 2 times negative 34 is negative 68. Okay, so now I have my equation in standard form, and if I line it up over here like so, then it lines up and I see that my y's are opposites. So I'm going to add. When you have opposite numbers, adding eliminates them. X plus 8x is 9x. Y plus a negative y is nothing, equals 356 plus a negative 68 means to subtract, so I'm going to have to take away from that 5 and make that 16, minus 8 is 8. Take 3 and make it a 2, and so I'm borrowing a 1. 14 minus 6 is 8, and I'm left with 2. Divide by 9 and we'll find x, which is the number of girls. This cancels. 9 times 3 is 27, so it's 3 with a remainder of 1, and 9 will go into 18 twice. Okay, so there are 32 girls. So then I'm going to substitute in, I'll do it in the original equation. If we have boys, or girls plus boys equals 356, and I just found the number of girls, which is 32, plus y equals 356, then I'm going to subtract 32 from both sides, and we'll find out how many boys are in this school. So these cancel, and I get y equals 6 minus 2 is 4, 5 minus 3 is 2, and we get 324. So y equals 324. So there are 32 girls and 324 boys in this school. Okay, example 3. A family member has some $5 bills. So I'm going to call $5 bills X. So I'll say let X equal $5 bill. And $1 bills. So have some $5 bills and $1 bills in her wallet. So I'm going to call Y. Let Y equal $1 bills. Okay. Altogether, she has 18 bills. So that there tells us that we have our first equation. So we have $5 bills plus my $1 bills equals a total of 18. So the number of $5 bills plus the number of $1 bills equals 18. and a total of $62. Okay, so now I need to identify what each of these things is worth. So in my second equation, since they're $5 bills, then I'd say $5 times how many of those $5 bills I have. So if I have one $5 bill, it's 5. If I have two, it's $10. If I have three, it's 15. And $1 bills are only $1, so that doesn't change. So $5 times however many of those bills we have, plus $1, which is the value of a $1 bill, and how many of those we have, equals our total of 62. Okay, so in this situation, the way I set it up, they're both in standard form, and I have y's that are the same, so I'm going to subtract. So x minus 5x is a negative 4x. Y minus a positive y is 0, so that goes away. And 18 minus 62 is negative 44. So I'm going to divide by a negative 4 on both sides. These cancel. I get x equals a negative divided by a negative is positive, and 44 divided by 4 is 11. So that tells me I have 11 $5 bills. So if 11 $5 bills, and they're $5 a piece, that's $55. So now I can easily determine how many ones I have to get up to 62. So now if I say x plus y equals 18, and my x is 11, then I get, oops. Let me try that again. Okay, subtract 11, subtract 11. Now draw my equal sign. I get y equals 7. So if I have 7 $1 bills and 11 $5 bills, that's a total of 18 bills in my wallet, or in her wallet. Okay. And now if I plug it into the other, it means that for a $5 bill is worth $5, and I have 11 of them, plus $1 bills, they're worth $1, so, and I have 7 of them, has to equal 62. This is 55. 5 times 11, and 1 times 7 is 7. And $55 plus $7 is $62. I wrote 66 for some odd reason. Must be too early. $62. 62 equals 62. Alrighty. So there you have it. Okay, next example. A friend bought 2 boxes of pencils. So let P be pencils. And 8 notebooks for school. So let's use N for notebooks. And it cost him $11. So that's our total. Okay, so if I set up an equation, he bought 2 boxes of pencils. So 2 boxes of pencils plus 8 notebooks equaled $11. So my variable is how much they're going to cost. Let's think about this for a second. Is that how that's going to work? That would mean that the price is changing. Okay, I think this is going to work, so let's just keep going. And then the second scenario is he went back to the store the same day to buy school supplies for his younger brother, and he spent $11.25, so that's his total, on 3 boxes of pencils and 5 notebooks. So there's my next equation, so I'm going to color code all this. So 3 pencils, 3 boxes of pencils, plus, this time 5 notebooks equals $11.25. Okay, so there's our 2 equations. 2 and 3 are not same or opposite. 8 and 5 are not same or opposite. So I need to do some sort of calculation here. So if I multiply the top by 3, I'll get 6 for the p's. And if I multiply the bottom by 2, I'll get 6 for the p. Or I could multiply top and bottom by 5 and 8. So whatever number you see here, you multiply the other equation by the coefficient of the other equation. So if I put this in parentheses and take this 3 here and put it here, 3 times 2 is 6. So let me move this over here, next, instead of underneath, just so you can see what we're going to do here. Okay, so if I took this 3 and put it out in front here, and now I put parentheses around this equation, and I use this coefficient of this p and put it over here. And then I'm going to distribute. So when I distribute, I get 3 times 2p, which is 6p, plus 3 times 8n, which is 24n, and then 3 times 11 is 33. So there's my first equation distributed. My second one I'm going to distribute, and I'm going to get 2 times 3, which is 6p, plus 2 times 5 is 10n, and then distribute here. And 2 times 11, 25 is 22.50. Okay, so now I have these two equations, and as you can see now, if I move this under here, they're the same. And so I'm going to line them up, and I'm going to use elimination to finish this problem. So now that I've done this, then I can draw a line here, and since they're the same, I'm going to subtract. 6p minus 6p is 0. 24 minus 10 is 14n equals 33 minus 22.50. I need to borrow some cash here and call this 9 and this 10. Actually, no, 0, 0, and I need to make that 10, not 9, and 10 minus 5 is 5. 2 minus 2 is 0, and 3 minus 2 is 1. So 33 minus 22.50 is 10.50. Divide by 14. And these cancel, and n equals... Okay, so now I'm going to take my calculator. I'm going to take 10.50 divided by 14, and I get 75 cents. All right. So that is n. That's the price of our notebook. We found the price of each notebook. Notebooks are 75 cents. Okay? So it didn't ask us to find the price of the pencils. I'm going to do it anyway, but it didn't ask. The question is asking right here, how much would 7 notebooks cost? Okay, so let me get this distribution stuff out of the way so you can read that. How much would 7 notebooks cost? All right, so now I'm going to take this 75 cents, substitute it into one of these two equations, kind of erase some of this. You can still see it. All right, so I'm going to substitute in. So if I have the original equation, 2p plus 8n equals 11, 2p plus 8, and my n is 0.75, equals 11. So it's 2p plus 8 times 5 is 40, 7 times 8 is 56, plus 4 is 60. So it costs $6 for 8 notebooks. And if I subtract $6 from both sides, okay, these are dollars, then I get 2p, 2 packs of pencils, equals $5. So if I divide by 2, then I get a pack of pencils costs $2.50. And the notebooks cost 75 cents each. So now what I need to do is, obviously you need to check that to make sure it's true. But I'm not going to do that in the video. I need to still answer this question though. How much would 7 notebooks cost? Well, if n is 75, then 7n equals total notebooks, and I'll just call it T. And so 7 times the number of notebooks I have at 75 cents will equal the total cost of 7 notebooks. 7 times 5 is 35, carry the 3. 7 times 7 is 49, plus 3 is 52, and I have 2 decimal places. So it will cost $5.25 for 7 notebooks. Okay, exercise 1. The exercises are due on your own, so try this. Pause the video, see how you did. So we're talking about cows and chickens. A farm raises cows. Let's call cows X and chickens Y. The farmer has a total of 42 animals, so X plus Y equals 42. Cows plus chickens equals 42. One day he counts the legs of all of his animals and realizes he has a total of 114. How many cows does the farmer have and how many chickens does he have? Well, you have to realize that cows have 4 legs. So I'm going to write this over here. Cows have 4 legs. Chickens have 2 legs. Okay, so now we're going to say, counting the legs of all his animals, he realizes he has a total of 114 legs. So since cows have 4 legs, it would be 4 times the number of cows you have is the number of legs you have on the cows, plus 2 legs per chicken equals 114. Okay, this is a funny problem. I like it. So let's just line these up like so. So now you look at these and you say, okay, well, we don't have any variables that are equal or opposite. So I can multiply this top one by 4, or I can multiply it by 2 in order to get one of my x's or y's to eliminate. So let me move this over here. And I'm going to focus on the y so I'm not making these values too large. So I need 2y, I need a 2y here. I'm going to try to avoid subtraction, so I'm going to multiply by a -2 to get an opposite of this. So when I multiply this, I get -2x plus, just kidding. Negative times a positive is minus 2y equals negative times a positive is negative. 42 times 2 is 84. So now I have -2x minus 2y equals -84. And if I take this equation and line up my terms, like so, and then calculate the sum, then I'm going to get -2 plus 4 is 2x. -2 plus 2 is 0 equals 114 plus a -84 or minus 84 is 30. And I divide by 2, and those cancel, and I get x, which is how many cows we have, is 15. So we have 15 cows on the farm. Old MacDonald's got 15 cows. E-I-E-I-O. Now I need to find out how many chickens he has. So x plus y, cows plus chickens, equals 42. And if he has 15 cows plus some chickens, that equals 42. If I subtract the cows from the total, then I get how many chickens I have. Okay, so x is 15, y is 27. Okay, how many cows does the farmer have? 15 cows. And how many chickens? 27. Okay, that was a... Okay, number 2, the length of a rectangle. Okay, now watch what I'm doing here. The length of a rectangle. I'm going to stop right there. I'm going to draw a diagram of a rectangle. Okay, and it says the length of a rectangle is 4 times the width. 4 times width. So there is my diagram. Length equals 4w, and w is w. The perimeter of the rectangle is 45 inches. So I'm going to write P equals 45 inches. What is the area of the rectangle? So we need 2 formulas here. We need perimeter and we need area. Okay, so area equals the length times the width. And perimeter equals 2 lengths plus 2 widths. So now I'm going to, I can't solve for 2 unknowns. I do know my perimeter is 45 inches, so I can put 45 in there. but I don't know the length or the width, so I can't solve this with two variables, so I have to put it in terms of one. So since the length equals 4w, then I can say 2 times the length, and the length is 4w, then 2 times 4w is the same as 2l, plus that 2w. So then when I distribute, I get 45 equals 8w plus 2w. 45 equals 10w. Now I divide by 10 and I'll find my width. When that cancels, w equals 4.5 inches. So I found my width. So since length equals 4w, then the length equals 4 times that 4.5. So the length equals, well, 4.5 times 2 is 9, so times 4 would be 18. So L equals 18. All right, so we have our length of 18, our width of 4.5, and we take those values and substitute them in to find our area. So length is 18 times, let me just use parentheses, 4.5. So the area equals, I'll just do this here rather than using a calculator. 5 times 8 is 40, carry the 4, 5 plus 4 is 9, bring down a 0, 8 times 4 is 32, carry the 3, 4 times 1 is 4, plus 3 is 7, 0, 9 plus 2 is 11, so I have 8, 10 with 1 decimal point, so the area is 81 inches squared. Okay, number 3, the sum of the measures of angle x and y is 127 degrees. So x plus y equals 127. If the measure of angle x, is, the measure of angle x is 34 more than half y. So x equals, or x is 34 more than half y. How can we represent that? Oh, I had it before. Let me get rid of that. I didn't write the 34. Okay, x is 34 more than 1/2 y. So you'd say x equals 1/2 y plus 34. Okay, I don't have this in standard form, so I'm going to subtract 1/2 y from both sides. So I get x minus 1/2 y equals 34. I don't want fractions, so I'm going to multiply by 2. 2 times x is 2x. 2 times a negative 1/2 is negative 1y equals 34. Okay, so I'm going to move this equation. Oh, I did it too quickly, so I just got to rewrite it. 2x minus y equals 34. Now we have differences of y's, and there now we can add. So if I add opposites, one goes away. So x plus 2x, that is an x by the way. X plus 2x is 3x. Y plus a negative y is nothing or 0. 127 plus 34. 7 plus 4 is 11. 3 plus 2, 5 plus 1, 6. And 1 plus 0 is 1. Divide by 3 and we will find the measure of angle x. 3 goes into 16 5 times. 5 times 3 is 15. Carry the 1. 3 goes into 11 3 times with a remainder of 2. So x is 53 2/3 degrees. Okay, sometimes I question when we get decimals or fractions, and I have made a mistake, so it's a minor one. I found it, so let's just go back here. And I forgot to distribute, and I'm struggling with my eraser here. 3 times is a charm. Okay, so right here, 2 times x is 2x. 2 times negative half is 1. I did not multiply my 2 times 34. My apologies. This is not 34. It is 68. Okay, so this is 68 over here. So I need to change that here. So if this is x minus y equals 68, and I add 8 plus 7 is 15. Carry the 1. 6 plus 2 is 8, plus 1 is 9, and then bring down that 1. The y is canceled, and I have 3x equals 195. Divide both sides by 3, and x equals 6 times 3 is 18. Carry the 1. 3 goes into 15 5 times. Okay, I'm happier. So x is 65 degrees. So if x plus y equals 127 degrees, and x is 65 degrees, I can find y by subtracting 65. Okay, subtracting 65 from both sides. This cancels. I get y equals 7 minus 5 is 2, and 12 minus 6 is 6. So y equals 62 degrees. So x is 65 degrees, and y is 62. And a total 127. Okay, that is the end of lesson 29. Go do your problems.